Okay, let's see how you did. So first of all, let's put back in our equation here. So the area of this sector is going to be equal to the measure of the arc over 360 degrees times the area of the circle. So pi r squared. So first, let's just get the area of the circle. Okay, so the area of the circle, pi r squared, is going to be equal to pi times the radius squared. Our radius is 9, so pi times 9 squared, that's going to be 81 pi. Okay, again, they want this in terms of pi, so don't start making decimals. Okay, just leave it 81 pi. Okay, so we have now area of the sector equals the measure of the arc times 360, or divided into 360 times 81 pi. Okay, so now what's the measure of the arc? Okay, they could put it up here, they could put it down here in the central angle, wouldn't matter, they're the same. So 84 degrees. So now we've got 84 degrees over 360 times 81 pi. So area of the sector. So now what we just got to do is kind of simplify this. Again, no calculators to make decimals. Okay, we want this in terms of pi. If they wanted this in terms of rounded to the nearest tenth, you know, you could start multiplying things and, you know, lastly multiply in pi there. But let's reduce this down here. So 84 over 360 first of all. Let's see what we've got there. I mean, let's see what we can get in there. We can probably get at least 4 into there. So let's take 4. Divide 84 by 4. We get 21, right? 21 times 4 is 84. So 21 over 360 divided by 4. Let's see, I'm going to actually make sure I get these right. So I'm going to go ahead and use a calculator. So 360 divided by 4, well, that's 90. Actually, I don't need anything for 90. So I can go further, right? Because those are both divisible by 3. So 3 goes into 21 7 times, and if 3 goes into 90 30 times, right? So 7 over 30. So we can have 7 times 30 times 81 pi. Okay, now I can continue because I can reduce 81 and 30, right? They're both going to be divisible by 3. So let's see, 81 divided by 3. Equals 27. So I can actually probably then, let's see here. Let's see, 9, yeah, I might actually be it. So let's see, 81 divided by 3 is going to be, oops, 81 divided by 3. If I can use calculator properly, we get 27. So 7 times 27 pi, and then we've got over 30 here. 30 divided by 3 is going to be 10. So that may be, let's see what 27 divided times 7 is. And you can see this is a little process simplifying here. So 27 times 7 equals 189. So we've got 189 pi divided by 10. So that may be the best we can do. 189 pi divided by 10. It's not very pretty, but 10 is divisible by 5 and 2, and that's it. And 189 is not divisible by 5 or 2. So that's it, 189 pi over 10, and that is in millimeters squared. So maybe not as pretty as a decimal might be, but that's going to be your final answer there. All right, hopefully you know, you were on the right track. You may not have gotten all the way down to that simplified answer, and that requires some practice, which we will do in live lesson. But hopefully you were able to kind of get started. If not, you can kind of see your mistakes now, and we'll keep working on it again in live lesson. All right, let's move on and look at segments. Okay, so the area of a portion segment of a circle now is going to be, a segment again is this little thing right here you see here. You're going to say, well, what the heck is that? Okay, so let's take a look at what it is. So it's an arc Okay, and if we draw in the radii from that arc, that segment is going to be part of a sector, right? And basically what's missing is going to be that sector is going to be a triangle here. And that triangle is what's going to be missing from that complete sector. So what we do is we find the area of the whole sector, we subtract out that triangle that's missing, and we're left with the area of the segment. Okay, so what we're going to need to be able to do is what we've done in the last slide, find the area of a sector. Okay, then we're going to need to do what we did in the last couple of chapters, which is find the area of all sorts of different triangles. And lastly, we're going to subtract, and we're going to end up with the area of the segment in question. So let's go ahead and do that. Okay, let's see. Problem 3. What is the area of the shaded segment shown? Round your answer to the nearest whole number. Okay, so we're not going to leave this one in terms of pi. So your calculator will be your friend in this one. So what is the area of the shaded segment? So here's our shaded segment here in gray. So we've got a 90-degree central angle. So now we've got a sector, okay, formed by a 90-degree angle with a radius of 7 inches. So what we want to do is first we want to find the area of the sector. So I'll draw my little piece of pie here. We want to find that area. And then we want to subtract out the area of the triangle that is part of that sector, but not part of the segment. So there it is right there. So we want to subtract that out, and then we're going to be left with our segment. Okay, so this problem will take a little bit of time, right? So let's take a look here. So first thing we've got to do is we've got to find the area of that sector. So the area of the sector is going to be, remember, the measure of the arc over 360 times the area of the circle. Whoops, that's supposed to be a multiplication sign, not an equal sign. Times the area of the circle. So the area of the circle is going to use our radius. Our radius is 7 inches. So we've got pi times 7 squared. That's going to be 49 pi. What's going on here? Ooh, what is going on? Having a little trouble writing here. So we got 49 pi for our area. We're going to be multiplying that times, okay, the measure of the arc. Well, the measure of the arc is 90 degrees. So it's going to be 90 degrees over 360. Okay, so now what we've got to do is we've got to go ahead. And again, I'm not going to multiply and make my decimals yet, okay, because I want to make sure that I minimize how much effect. So let me take the 90 divided by 360. I can divide 90 into both of those. I get 1/4. So that's going to be 1/4 times 49 pi. Okay, so that's going to be my, that's actually 1 times 49 pi. So it's going to be 49 pi over 4. So now, since we're just subtracting, you can go ahead. So I'm going to go ahead and get out my calculator, and I'm going to do 49 times pi equals 153.938, yada, yada, yada. I'm going to divide it by 4. And I get 38.484. I'm going to leave a few decimal places in here. So I'm going to go 38.48. So that's going to be 38.48 inches squared. So this is the sector. Okay, so 38, let's draw that right up here, 38.48, and that is square inches. Okay, so next I need to find the area of this particular rectangle. Now, this is going to take using some previous knowledge. So I've got a 90-degree angle there. I've got a radius of 7 inches. So what can I do now to figure out what the area of this particular triangle is? Well, a 90-degree triangle has something nice about it. If you think about 90-degree triangle, the base and the height, remember the base and the height must meet at a 90-degree angle? Well, the base and the height are going to be the two sides of this triangle, right? They're both going to be perpendicular because they meet at a 90-degree angle. So this one's kind of nice, right? And then what's the length of this other leg of this right triangle? Well, it's another radius, so it's 7. So we actually have enough information here. Area of a triangle is area equals 1/2 base times height. So area equals 1/2 base times height. Well, 7 times 7 is base times height. So area equals 1/2 7 times 7. So that's going to be 1/2 of 49, or 49/2. So that would end up being, what, 24.5, and that would also be inches squared. So 24.5 inches squared. So I left the easy part to you guys this time, okay, because I gave you a pretty hard problem on the last one. Go ahead and tell me what the final answer here is for the segments, okay? And then you'll be done. We'll go over it in the next slide real quickly, and we will be ready to move on to the live lesson on Monday.